A power grid operator must know at all times two main data points: how much power is going into the grid and what the demand loads are. With today's renewable sources like solar or wind, those things must be known real time and instantly. If you're transmitting hundreds of megawatts into the grid and then a cloud comes over, it can go down to nothing almost instantly. At nighttime, there's also nothing being fed into it. Another problem with wind or solar is they're rarely in the center of the city. The real estate's just too valuable. So they usually put these plants on the outskirts of town. We're in a desert. There's not much out there. So if you drive around town, you'll see a lot of solar plants that are constantly getting power into the grid. However, there's not a lot of telecommunications that goes around there. That's where I come in. I'm Brock Bites, and I run the internet. Here we are above Las Vegas at Apex Mountain. This is the mountain that sees over into a valley that goes all the way up to Arizona and finally Utah. This mountaintop is used for a lot of communications to different parts of the valley. Inside here we have the Speedway, and we have also Nellis Air Force Base over here. On this side, this is a great utility to Las Vegas. A lot of power for Las Vegas is generated over here. We have our dump, except landfill refuse, for about 200 years here in Vegas. And we have also a lot of solar plants all through here, hundreds of megawatts. This part of town is where we generate a lot of electricity. Over here, we have the Silverhawk power plant. It's a natural gas plant that produces 585 megawatts. And over here is the Chuck Lindsay plant. That's 1,102 megawatts, one of NV Energy's largest gas plants. And you can see all the little black specks. Those are all solar panels. There's a small one there that's 20 megawatts, and the one out there is about 200 megawatts that's producing. And a lot of power comes to this that feeds Las Vegas. So what is a megawatt? A megawatt is 1,000,000 watts, which is also 10,000 kilowatts. Your average home uses about 1,200 kilowatts, which, if you look at how much a single megawatt powers, it powers about 830 homes. So when you look at how much power that we can produce from a facility of even 20 megawatts, it's a little over 16,000 homes. One of the hard problems for me to address is there's so many stakeholders for the plants when they're building them to when they're operating them. Each one of them have different goals that they need for me to bring communications for. There's the plant builder. That's going to be like a construction company. They're going to need all their CAD drawings. They're going to need all the different specs on what they're drawing, and they're constantly in communications with their home office on, is this the right location to build this? Once that's done, there's the owner of the plant, and they're going to want to know how many megawatts they're producing and that everything's actually working to their specs. Someone's actually going to be buying that power from a thing called a PPA, a power purchasing agreement. Now, if that's in like California or other regulated places where they have a diversified grid, that's a thing like CalISO. They regulate all the power coming into the grid at all times. If it's a monopoly like Las Vegas, it's just NV Energy. They're going to be monitoring all the communications and making sure that everything works for their cities that they pump out power to. But all this is interconnected, so everyone really has to know all the telemetry at all times. So when these things are fully functioning, they need a lot of different types of line. It's not just an internet connection. It's actually private lines where they have SCADA networks. SCADA networks are private networks that actually are the control devices for the plant. Like little devices that will turn open a transformer or turn it off. When you hear about people getting hacked, those are the devices. They are SCADA devices, and they're usually on a super protected network. You never want them exposed to the internet if possible. A lot of these are unmanned. A lot of them don't have anyone there going around, but when they do, they're going to have someone working in an office. So they're going to be needing internet, and a lot of them also need Wi-Fi so they can walk around with their tablet and do checklists of operations. The last things that a lot of these things need are VoIP lines or even dial-up lines. They will be able to call 911 if something does happen, and that we have to make sure it works 100% of the time. All this stuff we really have to make sure it works 100% of the time, because if it doesn't, the plant will actually get turned off because they can't know how much data is going into the grid. If that happens, there's a lot of money that can be lost when these things get turned off. This solar plant over in front of the Silver Peak station, this is a 154-acre site. It has 88,000 polycrystalline panels on there that are generating about 20 megawatts of power, which is roughly 16,000 homes. This plant has a life expectancy of about 25 years. We're 8 years into that currently. Renewable energy is great for everyone. Here we are inside the shelter where everything actually connects, from the radios down to those lines inside that I show you at my data center. With the right software, a grid operator can maintain reliable communications and proactively do maintenance for all their panels to ensure that the grid is properly maintained with the sufficient levels of power. The combination of the hardware, the software, and the real-time communications is what allows us to actually get the cheapest power source there is. Nothing's cheaper than solar. Only problem is it's not always on. With a reliable network, we can modernize our grid, bring clean jobs everywhere, and ensure for a great energy-filled future.